Okay, good morning to those who are watching this video right now or later. Okay, so I'm from group 10. This time I will be taking the leader part of the group 10. So today we are going to discuss about experiment 5, which is the measurement of jet forces. So for the group 10, our team consists of me, Wong Run Lee, and then Nuru Patricia and Barwin, and lastly, Nuru Fiona. Okay, so that's the basic introduction for our group 10. So right now, this is basically the abstract of the experiment 5. So abstract is objects like boat or rocket are moving use the jet force method. Jet force is the exhaust from some machine like in the aircraft propelling the object itself in the opposite direction due to the change of the momentum. Some other objects that are using the same method are drones and satellites. Okay. This will be the objective of our experiment this time. So the objective is to compare the force exerted by a fluid jet impinging upon a flat plate or a hemispherical surface with the theoretical values. Okay, so this will be the basic introduction for the experiment 5. So the moving fluid may exert forces on objects in contact with it. The forces can be determined by using the Newton's second law or by the momentum equation. The force exerted by a jet of fluid on a flat or curved surface can be resolved by applying the momentum equation. Okay, so this time the abstract, objective, and introduction all are very simple and can be understood by the words. Okay, so for the next part will be theory. I will pass it to my team, Fiona, to continue. Thank you.
Thank you, Turuli. Hi and Assalamualaikum. My name is Fiona. Now we are going to proceed with the theory. So for the first point, according to the Newton's second law of motion, when a jet of fluid impinging is come into contact or strike a flat plate or a hemispherical surface, it will generate a force. This is due to the change of momentum of the fluid. For example, when a velocity of water from jet nozzle with diameter strike on the flat plate or hemispherical surface, the rate of change of momentum produced and its magnitude is the same with the force exerted on the surface of the flat plate or hemispherical in order to support the water jet. So basically, this point explains that the rate of change of momentum is equal to the force exerted on the surface of the plate, whether it is a flat plate or hemispherical surface. Okay, next, the F generated by a jet of water when it strikes depends on the shape of the surface. So basically, the force generated depends solely on the shape, whether it is flat or hemispherical. Figure 1 and Figure 2 depicts a jet of fluid issued from a nozzle of diameter moving vertically upward with velocity v1 and strike a flat plate and hemispherical surface respectively. The jet is deflected by the surface of flat plate hemispherical through an angle theta and leave the surface with velocity v2. Okay, we can see from this figure 1 show that jet of fluid strike a flat plate. So you can see this is the flat plate. And figure 2 show that jet of fluid strike a hemispherical surface. So this is hemispherical surface. Okay, next. The theoretical force generated when the jet of fluid strike a flat plate is F equal to rho A V1 to the power of 2 minus rho A V2 to the power of 2 cos theta. Okay, from this figure 1, we can see that V1 is vertically upward while V2 is to the left and to the right. Guess that V2 make an angle of 90 degree with V1. So basically, when the angle is 90 degree, cos 90 degree will become 0. So this we can eliminate. Here we can write equation 1 as F equal to rho A V1 to the power of 2 only. For the hemispherical surface, the theoretical force generated is F equal to rho A V1 to the power of 2 minus rho A V2 to the power of 2 cos theta. Here from figure 2, you can see that V1 is vertically upward, while V2 make an angle of 180 degree with the V1, or we can say that V2 is opposite of V1. Okay, so equation 3 can be written as F equal to 2 rho A V1 to the power of 2. This is because we will have 2 V1. So basically it is opposite. So minus minus will be positive. So it will become 2 rho A V1 to the power of 2. Okay, where F is the theoretical force exerted on the flat plate or the hemispherical surface. Okay, the unit is Newton. And A is the cross-sectional area of the nozzle. The unit is m to the power of 2. And this is the density of water. The power is kg per meter cube. And theta is the angle of water flow after impact of the flat plate or hemispherical surface. V1 is the velocity of water jet before the impact, and V2 is the velocity of water jet after the impact. So that's all from me. I will pass my presentation to Batrisha. Thank you.
Hi, Assalamualaikum. I am Nur Batrisha. So I will continue with methodology for this experiment. So we start with looking at the apparatuses. So these are the apparatuses that have been used. We have weight position, we have deflector, we have nozzle, lever mechanism, tank, water supply, water drain, main switch box, flow control valve, volumetric measuring tank, and sliding valve. So now we are going to look at the very first step of this experiment, which is determine two different type of deflector. So as you can see here, we have two different type of deflector. On the left picture is the flat surface deflector, and on the right picture is the hemispherical surface deflector. Then second step, remove cover together with the lever mechanism. So these are the cover. This is the cover that have been removed. And then continue with assembly the tested deflector and start with this flat plate. For the fourth step, place the cover with assembler plate at the lever mechanism back into the tank. And then tighten the 3 screws to the cover. So these are the 3 screws, and we put back into the cover, which are here, number 1, number 2, and number 3. So for the step number 6, set the pointer to 0 by adjusting the screw at the lever mechanism. So this is the screw. After that, we are going to turn on the main switch and pump. And then slowly open the flow control valve to the maximum flow. So rotate this orange color here until the control valve to the at the maximum flow. And for the step number 9, put the desired weight on the lever mechanism. So as you can see, this white color is the weight that we put on the lever mechanism. Then when the pointer at lever mechanism is at 0 notch, as being shown by this red color of arrow, stop put the weight. And then close the sliding valve by pushing this red button over here. Then determine the flow rate by recording the reading time required to fill up 3 liters volume of water with volumetric tank. So we can use stopwatch. And then after finish up, for the second reading, reduce the desired load weight. This white color here, we just reduce the weight. and then adjust the flow control valve. And for step 15 and 16 is just the same with step 10 and 12, which are stopped until the pointer at the level mechanism is at 0 notch. And again, record the time required to fill up 3 liters volume of water in volumetric measuring tank. And then we will continue repeating the procedure by decreasing the desired weight until the flow control valve is at minimum opening. And then after finish up with the flat surface deflector, repeat the procedure using appropriate load weight and change the deflector from flat plate to a hemispherical surface. So these are the weight, and this is the hemispherical surface that we use to replace the flat plate. So I think that is all from me. My friend will continue with result and discussion. Thank you.
Thank you to my friend Patricia on the explanation about the methodology for this experiment. Now I am Bhavin. So I will be presenting about the results and the discussion for this experiment. So this is the table or the results for this experiment for the flat plate. So the measurement force F measurement. So these are the datas, and the volume of water collected in liter. So it's constant, that's 2, and time taken for the water to be collected is noted. So we calculate Q by dividing volume of water collected over time. So these are the results that we get. So for the V, as we all know, Q is equals to area multiplied with velocity. So we already know the Q, so we just use the formula Q is equals to AV to calculate our V. So and then for the theoretical force, as we all know, for the flat plate, the theoretical force F theoretical is equals to rho A V square. So and then we calculate the percentage of relative error. So we modulus that thing. So the error always positive. So and for the hemispherical plate also the same. So but for the theoretical force for this hemispherical plate, so there will be F theoretical is equals to 2 rho A V square. There's 2 in front of the formula. So also for the percentage of error, we modulus that thing, so it always positive. So for discussion number 1, plot a graph of log F measured versus log V for both the flat plate and hemispherical surface on the same graph. So these are the datas when we log V and log F measured, and also for both flat plate and hemispherical plate. So here in one graph, we plot both of the graphs for flat plate and hemispherical plate. So this one, estimate the slope of the graph for both the flat plate and hemispherical surface and compare with the theoretical value as shown in equation 2 and equation 4 respectively. Comment on the difference. So the slope of the graph for flat plate and hemispherical surface is a linear graph. So by logging both sides of the theoretical equation for the flat plate and hemispherical surface, we were able to get the equation something like for the flat plate, it would be log theoretical F theoretical is equals to 2 log V1 plus A, and for the hemispherical surface, it would be log F theoretical is equals to 2 log V1 plus A. So the equation above is similar to the equation of line where y is equals to mx plus c, where the m is the gradient of the graph and c is the intersection at y when y is equals to 0. Thus the graph obtained is correct, because as we all know, in the previous slide we already can see the graph that we plotted is a linear graph, so it's correct. So for the flat plate, the gradient would be 1.813, and for the hemispherical surface the gradient is 1.687. There is a difference between the value from slopes in graph and the theoretical force for hemisphere and flat plate. This is because there is different in the force impact toward the plate surface due to the different angle of the water impaction, causing the value of the slope in graph is different than theoretical value. So for B, estimate the y-intercept ratio of hemispherical surface to flat plate and compare the theoretical ratio as deduced from equation 2 and equation 4. Comment on the difference. So as we all know, for the flat plate, so y is equals to mx plus c. So we calculate, we substitute all the values, we will get y c is equals to negative 0.9926. So y intersects is negative 0.9926. And for the hemispherical surface, we would get y intersect is negative 0.5363. So as we calculate, the y intersect ratio is 0.5408. So we calculate for the theoretical ratio. So as we all know, we go back to the previous equation where we log both sides. So we use that equation to calculate the y-intercept, where in that equation that's A. So the theoretical ratio would be 0.5438. There's a slightly different in the ratio between the y-intercept as in the calculation compared to the theoretical ratio. So in real situation, there will be minor and major losses of the fluid when going through the pipe and striking the plate. So there is a difference between theoretical value and measured value. So compare the force exerted on the hemispherical surface with the one on the flat plate, which one is greater and why. From the experiment, we can say that the force exerted on hemispherical surface plate is higher due to the moment produced, which is higher than flat plate. The force exerted on hemispherical plate is greater than flat plate because it lies on the behavior of the water jet when it strikes the flat surface. It forms a radial sheet which impinges on the inner wall of the surrounding cylinder and then divides, some of the water flowing down the cylinder wall and the rest flowing upwards. Although visibility is impaired by the spray which is generated, it does seem that some water falls on the top side of the vane. This would have the effect of producing a small moment force in the downward direction, so reducing the net upward force on the vane, where for flat plate the theta is 90 degree and cos theta is 0, which we get the force for plate is only F theoretical is equals to rho AV square. For the hemispherical surface, the theta is 180 degree, therefore cos theta is -1. So we substitute, so we will end up with 2 rho AV square. From the equation itself shows that the force act on hemispherical surface is 2 times greater than the force exerted on the flat surface. So compare the percentage of relative error for both the flat plate and hemispherical surface as function of jet velocity and comment on the analysis and explain your reason. So comparison between the percentage of relative error for both of the plates. Based on our data, the percentage of relative error for both plates are different. That is 20.09% for the flat plate and 2.14% for the hemispherical surface. From the experiment, we can see that the percentage of relative error for both of the flat plate and hemispherical plate surface shows a fluctuation, which is from higher goes to a low and goes back to high. The slope of the plate can be the source of error. This is because the equation using the angle, which is impact of the velocity from water to the surface of the plate. Plate is not in perfect shape, or in case got incomplete sphere. The angle will be different, which results in obtaining a different force. So other possible source of error could be the spring coil. The shape of coil must be in standard position, which is straight. If not, the velocity which is applied by the water is inaccurate. So, and then for briefly discuss on factor contributing to error and inaccuracy in experimental data and the possible recommendations to improve the existing results. So factor is contributing to errors. There are parallax error due to the position of eyes, which is not perpendicular to the scale of measurement and the reading. And the second factor could be the control valve may not be fully open, which will affect the results and cause the reading to be slightly off. And the third factor might be the spring used also may lose its elasticity, and this can cause systematic error and all the reading will be wrong. And last, the factor that might contribute to errors is error in calculating due to the uncertainty in measurement as well as mistakes made during calculating the results. So based on the errors, there are some recommendation to improve these results. First one, the position of eyes must be perpendicular to the calibration to avoid parallax error. And for the second one is to ensure that the control valve is fully open before adding the weights. So the third thing is check the spring before conducting the experiment and replace the spring if necessary. And for number 4, repeat the experiment at least 3 times for each reading to get the value by finding its average. And for the last recommendation would be use plates that have a perfect shape to increase the accuracy of forces exerted on the plate and thus giving a more reliable data. So now I will be talking about the suggest 2 application of jet impact in industry. So the first impact of jet is used to rotate the turbine, namely Pelton wheel in the generator. The water jet applies force tangential to the wheel. The tangential force of water jet generate moment or torque on the wheel to its maximum value. Therefore, it increases the mechanical energy of Pelton wheel, and the rotational energy of wheel is then converted into electrical energy. For the second application would be jet impact is also used as water jet cutter. Water jet cutter is capable to slice metal or other material by using the higher pressure and velocity of water jet together with abrasive substance. So the process of water jet cutting is similar with water erosion found naturally but occurs with highly accelerated and concentrated. So that's all from me. So I'll pass the presentation to my friend.
Okay, so thank you, Bhavin, for sharing the discussion and tabulation of data. So right now I'm going to wrap it up with our conclusion that have been made during after we have done the experiment. Okay, so the conclusion will be the objective of this experiment is to compare the force exerted by a fluid jet impinging upon a flat plate or a hemispherical surface with the theoretical value, which already stated just now in the objective part. Okay, so in this experiment, we can conclude that the force exerted on the hemispherical plate is greater than the flat plate. Okay, so this experiment also gives us a good knowledge of how the jet force works. So maybe after that, we can imagine it by applying the same theory with the satellite and so on. So maybe we can create something more better or make anything or better experiment in the future. Okay, that's all from me. Thank you. This will conclude our presentation.